I'm going to give you a brief overview of how we are assembling the regional map. What we're doing is we are taking gridded data and we are bringing those gridded components together to create the overall product. And so whether we receive gridded data directly from people, if we do that, then it falls directly into our GIS space where we do this assembly. If we get isolated depth measurements, if that's ENC points or single beam points or crowdsourced bathymetry, anything like that, we grid it ourselves into a small compilation, and that comes into this GIS framework to assemble all these pieces. And then in some cases, we get raw and or processed multi-beam data in a swath format, so a native multi-beam sonar format, in which case we also assemble that into gridded data and bring it together. On the right here, I'm just showing a few examples of some of the data that have come in as individual components. So the top left image is a gridded data set actually derived from seismic imaging that was made available by the US Bureau of Ocean Energy Management. The top right, which is a little bit outside the region, but nevertheless, that shows various NOAA data. Largely what you're seeing there is the US East Coast, but there's also data in the Gulf of Mexico. As we move down the examples here, you can see some individual grids from different countries within the region. And then on the right in the middle there is this very large digital terrain model that we got from Brazil. So these are very coherent. The point here is they're coherent survey areas. And so they kind of come in like puzzle pieces, really, and they fill in the spaces. The more complex one, this bottom right example, is all the individual multi-beam track lines that we get where we're actually gridding this data and cleaning it up. And it's more of a distributed, sparse grid that we also integrate together. So when we take all these pieces on the right and put it together, we end up with something like is shown here on the left. I just wanted to explain how we're really working primarily with gridded data, whether it comes in that way or if we're gridding it ourselves. I wanted to spend a little bit of time discussing the type identifier or the TID grid. And so with the JEBCO compilation that you can download from the JEBCO website, which I'll show you in a little while, alongside that elevation grid is a TID grid. It's a companion. There's the same number of grid nodes. And every grid node in this grid, instead of being populated with an elevation value, is populated with an ID that corresponds to the kind of instrument that was used to acquire that data. This helps us distinguish direct measurement from indirect measurement. It really helps us identify the kind of data that goes into each of these grid nodes. And it also helps us prioritize how the different raster layers, the different gridded layers, come together to build the compilation. So for example, we'll prioritize multi-beam data over single beam data because the resolution and the quality of that data is better. One example of the use of the TID grid, and hopefully this is easy to see here, but this is an example from the MH370 data set that was contributed in the Indian Ocean. But it's a nice example to show. In the left here is the bathymetry, and there's some portions of this image that are crisper and have more detail, and there's other portions that are less detailed. And if we look at the corresponding type identifier grid, it becomes very apparent that the crisper, more focused data is supported by multi-beam, and the blurrier data that's more in the northwest corner is actually predicted bathymetry. That's why it's less detailed. With this kind of information, people can better understand what they're looking at. They could extract different portions of the grid if they chose to, just to look at data that was acquired with different devices, that kind of thing. So another really important use of a type identifier grid is to help us distinguish from areas that are mapped from areas that are unmapped. And so in some cases, we'll get a pre-generated grid. The pink in the left image here is a pre-generated grid. You can see other data types with different colors that sort of fill in the area around it. But if we look in more detail at what supports that pre-generated grid, you can see that there's single beam data, which is represented in the darker green on the right. And then we can also identify where the areas of interpolation are. So with this information, we can better describe the fact that this whole area seems like it's been mapped because there's a grid covering it, but in reality, only portions of it have direct observations and the rest of it is interpolated. So this is really important when we're really trying to figure out what has been mapped, what has been imaged directly, whether it's an acoustic observation or an optical observation, right? So we really want to be able to distinguish this kind of detail as we build the product. This is an easy visualization that we can produce based on the type identifier grid. Basically, we can identify different portions of the JEBCO grid that are not based on direct observation, and we can make those black. And so effectively that covers up the portions of the ocean that aren't yet mapped, and it's a very easily understandable way to visualize where the gaps in the data are. So just in case you're not sure what you're looking at here, the gray is land, obviously. The blues are the bathymetry data underneath the depth, so the colors change based on depth, and the black is the area that's not mapped. And of course, as you zoom in, the small little track lines of data become more apparent. It's not entirely black as it looks at this scale, but as you zoom in, you can actually see where the data gaps are. I just wanted to emphasize that it's important to provide this kind of information, particularly if you're sending us a grid that is the combination of observed data and interpolated or predicted data. And so a good example of that is the Brazilian DTM that was contributed and has been included in the JEBCO compilation. The contribution is the image on the right there, that's the bathymetry data. And the image on the left shows all of the different supporting data that went into creating that. So all the track lines and survey areas. And we can take that, we can actually split that grid apart. So we can show the difference, or at least tag differently as we assemble the data, the predicted bathymetry from the observed bathymetry, and we can better describe where the gaps are.